Hey everyone, welcome back to Recent Advances in Technology. My name is Jamie Boisvenu. Today's date is December 4th, 2014, and I am pleased to present to you today my P3 idea, which is magnetic levitation escalators. So just a brief overview of what I'm going to cover today involves current challenges of escalators, what magnetic levitation really is all about and how the system works, and then I'm going to talk about some of the tactics of this innovation and how the principles can be applied to other applications other than just escalators. So some of the current challenges with conventional escalators today is that they're full of mechanical moving parts, and these parts, they wear down and eventually stop. The disadvantage of this is that escalators can be often down for maintenance for extended periods, and the important thing here is not to panic. People like Mayor Don Iveson has brought this issue to attention as it continues to be a reoccurring issue. It's not only a local problem. Karen Lee Benson in New York City has a problem meeting timely schedules for her kids to bring to appointments because she has to take the stairs because the escalators are always broken. The New York Times recently did an article on her in 2011 about this issue and how it is a growing concern. And with that, we need different technology. So, what is magnetic levitation? Well, Lenz's law states it as when magnetic fields cross each other, they create opposing magnetic fields, and this causes them to levitate. On the other hand, the Meissner effect is also a similar thing where supercooled magnets become superconductors and they create forces that provide suspension without any physical support. So as you can see, Lenz's law, as described, when a magnet opposes these magnetic forces, it creates new magnetic fields. I don't know if you have done it, but when I was younger, I used to put magnets together and I could feel that opposing field. That is Lenz's law, or magnetic levitation. This kind of technology is seen in the bullet trains, the Shanghai maglev train, and trains that are developed in Germany. They use this technology of these north-south pole magnets on the train and the track that use it for self-propulsion. And the theory behind that is that it creates linear motion. So these north and south magnets can continually move the train forward. McGill University talks about the development of superconductors using the Meissner effect, and it changes the magnetic field. So imagine these three magnets together as the train track. The superconductor magnet is the train. When placed on the track, these opposing forces allow the superconductor to float across the track. This kind of technology is applied, and they demonstrate this using this train model. And so this kind of technology can be used in escalators, I'm hoping. Hopefully we can replace these conventional systems of gears and wheels and levers and pulleys and take the existing infrastructure and use the tracks and implement magnets so that steps will move on their own. Some of the tactics of innovation include the upside, which is reduced downtime and repair costs. Unfortunately, it still does require power and/or supercooling magnet. Second to that, it is very seemingly simple. It eliminates the use of complex gears and motors. You can simply just use magnets. Third to that is the compatibility. So it uses existing infrastructure. The steps can be retrofitted. The credibility in this scenario is that my science background is there. The performance of the maglev train, I hope, would have convinced you that this is a good idea. And lastly, the easy in and out. It reduces maintenance costs, and if the system fails, you can use backup motors. Some of the applications in which this can be used are elevators, skylifts, and assembly lines. This is going to be a big hurdle, but I believe that if we have a good team of scientists, we can actually create this system and it will work. So I'd like to take a moment to open this up to any questions, and thank you for watching. I hope that you enjoyed it.